Greetings, Saintsmen. We got lesson 10.7, which is circles in a coordinate plane. And you guys have figured that this would always come here in this direction. So we've dealt all these issues regarding the various instances of chords intersecting circles, and not just chords intersecting circles, lines intersecting circles, and not tangents, secants, and so forth. And then giving you various lengths and as they relate to a circle, but we really haven't discussed what happens when you get this in a coordinate plane. Now, let's discuss function real quick. Remember, for something to be a function, you're going to have the following happen, right? We're going to have the xy coordinate plane, and I always utilize the following. So I remember years ago with my brother, I had a girlfriend who was taking calculus, and I always wind up being this guy because I'm a math teacher, and I wind up with other people's problems. I wind up with their math problems, and just it's always like, here, how do you do this? And it's stuff that's really out of left field for me. Well, I know calculus, and I've taken calculus. I took calculus over, at this point I'm 41. I took calculus over 20 years ago. I took it, when I was just turned 18 years old as a freshman in college. So it's one of those things where, yeah, I know how to do it. I've done it before, but it's of like a really odd little pieces of your education. It's like being asked about things that happened in your fifth grade history class or fifth grade social studies class. You know what I mean? It's really odd and specific questions. My point being, what is a function? Is a circle going to be a function as it pertains to a coordinate plane? Now, remember what a function is. Like, this is a linear function, for example. What it means is that for every single input, there's exactly one output. So there's not multiple outputs for an input. But the way that we really do this thing is we do the following. We create the vertical line test. Because when we do that, for every single output, right? If you look as we move this red line along the black line, every single time on the x-axis, it will have one y that it's going to touch. Now, think about this. If we're going to do the same thing, and let's take the quadratic, because we just discussed those in the most recent lesson, right? We discussed quadratics. This is the thing with something where we have the x squared term. Again, if you take this y, right? Or if you take this red line, this vertical line, every single place it touches, the graph of that quadratic, which the name of that graph is a parabola, if you guys remember, it's only going to be touching the graph in one place. All right? So when we have a circle obviously isn't going to do that with the vertical line test, right? The circle is going to be a line that's going to be a tangent only at one point. After that, it's going to be a secant through the rest of the circle. So circles are not functions. However, they have equations. And here's the equation for a circle. R squared is equal to the quantity x minus h squared plus the quantity y minus k squared. Holy cow. There's a lot going on here, but not really. Gentlemen, let's just know what these things stand for. For the first part, we already know what R is going to mean. In a circle, what would you think R would be? But of course, it pertains to radius. Okay? Now, x and y, I'm not focused on. I'm really focused on these weird variables h and k. Now, if you guys recall, we've dealt with this with regard to the point slope formula, right? Remember, guys, the whole thing of y minus y sub 1, right, is equal to m times the quantity x minus x sub 1. So we had this opposite, right? And this was a coordinate from which we started the whole thing. When we have this, h comma k are really going to be the h for the x and the k for the y. They're going to be the variables for the coordinates. Or for this case, the coordinate of the center. Because think about how complex it isn't to construct a circle. What do you need to construct a circle, guys? you need a compass. What does a compass deliver for you? Where there's the needle that does the center, and then there's the point that does the radius. It's that width between the two of them. So that's all you need. You need a place to start, put down that thing, and swirl around to get your circle. All right? It's pretty straightforward. So, as you guys remember, so let's take this thing, like, for example, I'm just going to give you like a little example here. If you had a slope of 3 and a point of 2, 1. Excuse me, 2, -1. And we want to put this in slope-intercept form that I just talked about. Right? How would we do this? Well, it's going to be y. It's going to be this. There is your y sub 1 minus, it'll be plus. M, of course, is your slope. That's your 3. And then x is going to be, we're going to put in the 2, and it's going to be a -2. You guys got it? So then this is how we're going to deal with this. We're going to create an equation for a circle with the center of 5, 4 and a diameter of 6. This is the entire thing you're being requested. You guys, you should be pumped about this as a test question. You know why? Because here's your center. Center, this is H and K. Boom. Now the diameter of 6. Well, if your diameter is equal to 6, what is your radius equal to? Half that, which is 3. So now we plug it in. It's r squared, which is 9. All right? 3 squared is equal to x minus, here's your h, which is 5, squared plus y, and what's your k? All right, y minus k, in this case, it's 4 squared. Gentlemen, this is it. That's it. You're done. All right? It's not that crazy, not that complex of a thing to do, okay? Let's try another example. This is literally going to be the equation, the types of questions you're going to get on your homework and what you're going to get in your next test. And again, you should be pumped for this one. The point 4, 1 is on a circle with a center of 1, 4, and you're going to write the equation for that circle. All right, so gentlemen, we need to find the radius. We need to find r. Excuse me for a second, I need to blow my nose. My apologies. We need to find r here, right? So what we need to do in order to find r is the radius is going to be the distance between any point and the center of the circle, right? If you have this and here, right, and then here you go, this right here is r. So we're going to need to find some sort of distance. So your r, we're going to use the distance formula, right? And we're going to say it's going to be 4 minus 1, the difference of the y squared, plus the differences of the x's, 1 minus 4 squared. All right? 4 minus 1 is going to be 3 squared, plus negative 3 squared, right? Square root of 9 plus negative 3 squared is 9. Or in other words, your radius is rad 18. Now, I'm going to leave it as that rather than to simplify this guy as 9, or as 3 rad 2, right? Because 9 can be simplified. Now, or rad 18 be simplified as 9 times 2, square root of 9 is 3. I'm not going to do that, because watch what happens. Remember what your equation was. Go back up here. This is r squared, right? So I'm going to square that r anyway. So what's rad 18 squared? But it is 18. And that's equal to, and now we just got to look at what our center is. The difference of x minus, and then my h in this case is 1. So that's x minus 1 squared. And my y in this case is minus 4 squared. And there we go. All right, gentlemen. So some Algebra 1 review. You guys ready? Let's review completing the square. Now, we talked about in class, we've talked about this notion of solving a quadratic, which we have factoring. We have the quadratic formula, but the second thing that we usually we consider is completing the square. So let's review what that is. This was something that was taught in Algebra 1 by all your Algebra 1 teachers. X squared plus 6x plus 8 is equal to 0. The key to completing the square is the following. To complete the square, my little motto is half it and square it. And what we're referring to it is the b term. Now, the b term, I'm sorry, and the b is what should be in quotations, not term. It's this guy right here. It's the 6, okay? So, in order to do that, in order to half it and square it, I need to clear out the c term, right? Because this is a, this is b, and this is c. Whatever's with the x squared, that's the a. Whatever's with just the x, that's the b. Whatever's by itself, that's the c. So I'm going to move this 8 away so I can clear out the c term. All right. And now I can take a look at this guy. Now, I'm using an example here that we can factor easily. X squared plus 6x plus 8. You guys can factor that. You already know what the answer is, right? It's x plus 2 times x plus 8. It's the two factors of 8, which, right, is just 4 and 2. That when you take the sum, it's going to be 6. I hope that makes sense. So we can do that. We can solve that. X plus 2, x plus 8, or x plus 4, excuse me. X plus 2 is x plus 4. So when you solve, you're going to get -2, -4. I already know what the answer is. Some of you guys did this in your head. That's not the point. We already should know what the answer is. So that way, when we complete the square, which we can always use, versus factoring, which we can't, in this case, we already know what our answer is going to be. So I'm using an obvious example. It's like this, guys. Remember this problem? Right? X plus 1 equals 3. And of course, you know the answer is 2. But the whole thing is we use this as the example. So it's -2, -3, -1, -1. So that you guys can see the inverse operation methodology. So here, we're going to half it and square it. Now, half it, which is half of 6 is 3. And square it, which is 9. And that's what we're adding to both sides. Okay? So now I have a binomial square, because I could take this right over here, x squared plus 6x plus 9, and if I unfoil or factor it, I have x plus 3 squared. If I take the half, that's what's going to go in here, the 3, and I'm going to square that thing. Now I'm going to take my sum of -8 and 9, and that's 1. All right? Now, to solve it, I got to get x by itself, so let's just take a square root of both sides. All right? Square root of x plus 3 squared is x plus 3. Now remember, what's the square root here with 1? It's plus or minus 1, right? Because remember, if I have x squared is equal to 49, what are my two things that work for x? It's not just 7. It's a positive 7, but it's also a -7 that works in here, and it's true. So we have to make sure that when we take the inverse, that we also do the same thing, right? So I'm going to subtract 3 to get x by itself. So I'm going to have -3 plus or minus 1, which really means I have -3 plus 1, and I have -3 minus 1, which -3 plus 1 is -2, and -3 minus 1 is -4. Those are my two answers, which should make a lot of sense, given that when you guys went back up here with x plus 6 plus 8, right, we knew that this was going to be x plus 2 and x plus 4 anyway, equal to 0, and that was going to yield the same solution here. But just shows you it's another methodology to make this work. And gentlemen, you need to know how to complete the square in order to do these final problems. You guys ready? And here's where it's going to get challenging for your last examples for this chapter. I'm going to give you guys an equation. X squared plus y squared minus 2x plus 6y minus 6 equals 0. And we're going to find the center and radius. Let's find the center and radius. Okay? Now, first things first. We're going to clear out this 6. This is going to be my b term on both. Okay? So, now I've got, when I group this thing. I'm going to put all the x terms together and then all the y's together. So I have x squared minus 2x. And then now I'm going to leave some space. And now I have y squared plus 6y. And I still leave some space. And I've got 6, right? Because I had 0 plus 6. And here's why I'm leaving some space. I'm going to complete the square in both of these. You guys ready? Half it and square it. Because I have this right here as my little partially done completion of the square. It's this step right here, back at completing the square. So I have x squared minus 2x, so half of negative 2 is negative 1. Negative 1 squared, half it and square it is positive 1. Next, I have y squared, which I had added anyway. Sorry. Here's my b term. Half it, 6 is 3. Squared 3 is 9. Now, gentlemen, look what I can do here. I can create the following. Now, this is what happened, though. If you add this 1 and you add this 9, you can't just add 1 and 9 just because you want to. 1 gets added, 9 gets added to both sides. And then I'm going to create my equation for circle, right? Which is the x minus h squared and the y minus k squared. But first I'm going to start by finding my radius, which is going to be 6 plus 1 plus 9, right? Which is 16. And then now I have this, which is a binomial square, right? This, if I factor it, is x minus 1 squared. Again, half it. Half of negative 2 is negative 1. If you guys were to take this portion right here and refoil it, you are going to get x squared minus 2x plus 1. Next, this right here, y squared plus 6y plus 9. I promise you that is y plus half of 6 is 3. Gentlemen, that's your equation for your circle with a center that you can decipher and a radius that you can decipher. What's your center? Well, it's h comma k. So in this case, it's the opposite of negative 1, which is 1, and the opposite of positive 3, which is negative 3. And the radius is the square root of 16, right? Because it would be r squared. So my radius is 4. That's what I'm doing to satisfy the question, which is to find the radius and center, and I have. I have a feeling to complete your practice test and to study for your test, you're going to probably watch the example a couple times. Let's do another one for practice. We're going to find the center and radius. Okay? Of the following, x squared plus y squared minus 8x plus 6y plus 9 equals 0. Now, gentlemen, as I start this problem, first things first, I got to clear out the c terms. So let's get rid of this thing, the little constant right there. To get my x squared, I'm going to put my x's together, minus 8x, and put my other terms together and leave a space, right? So I can complete the square. So I have plus my y squared plus my 6y. And that is now all equal to, left my little space for the y's, right? So I can complete the square. This, which the sum of 0 and negative 9 is negative 9. Okay? So let's complete the square. Here's one b term, half it, and square it. Half of negative 4, excuse me, guys. Half of negative 8 is negative 4, and squared it is 16. Got to add it to both sides. And then I'm going to do my half it and square it, right? For 6. Half of 6 is 3. 3 squared is 9. So I'm going to add 9 again. All right? So now I got my x's. And I'm going to create my little binomial square. Right? Half of negative 8 is negative 4. So x minus 4 squared. Half of positive 6 is 3. And then now I just need to take this sum. Negative 9 plus 16 plus 9 is 16. My center, so h and k, right next to x, the opposite is 4. And next to y, the opposite, -3, right? This guy right here, right? This is where I got my 4. Showing again, back at the top. Some of you guys are probably thinking, whoa, bro, why'd you get -4 and this turns into 4? Go back. Look at what your standard form of your equation is, right? X minus h. Remember how we did point slope, right? It's the opposites for that standard form. And then for this last one, we have our center. Now we need our radius, which again, this is r squared, so my radius is just 4. All right, gentlemen, I'll see you in class. Good luck.